All right, number 76. So I have a negative exponent here. So if a negative exponent is applied to a fraction, right? So if the fraction's inside the parentheses and you have a negative exponent on the outside, remember that you can flip that fraction over. Okay, so this will turn into x over 1, right? And anything over 1 is itself, right? So I actually don't need the over 1. And then I can change the negative exponent to a positive, right? So once you flip it, that changes the sign of the exponent, okay? So if a negative exponent is applied to a fraction, you can flip the fraction and change the sign of the exponent. So now I have x to the first power, right? And we know anything to the first power is itself, so I actually don't need the exponent, nor do I need the parentheses. So that's actually just x. All right. So, there's a lot of nuance with some of these things, and so that's why I wanted to show you more examples just to make sure that we're clear on all these, just little variances and in examples and so forth. All right, so 78. So here, I don't really have anything to operate. I have 3 multiplied by b to the negative 6. The 3 and the b, I can't simplify that anymore by, multiplying or anything. So I can't, there's nothing really that I have to simplify with the 3. It has its own exponent of positive 1, which is fine. So I'm just going to leave that 3. There's no other number to operate with it. The b, there's no other b there, so I'm not using product rule or quotient rule or power rule or anything, but I do have a negative exponent, and so I'm going to drop it, and so it'll go to the bottom underneath the 3, and the exponent will become positive. All right, and that's simplified as far as we can go. Positive exponent, our constants are simplified. We don't have any other b's, any other of the same base, so that's as far as we can go. All right, now remember that this exponent didn't affect the 3, right? The 3 has its own exponent, right? So once again, exponents only affect what they're directly touching, okay? All right, number 80. So here, I have 6 to the negative first power. I have another constant up top, but I don't want to operate with those until I deal with this exponent, right? So I'm going to deal with the exponent first. Now remember, if they were like bases, we could maybe use one of our properties, but they're not like bases. So that's 6 to the negative 1 power. I want to make the exponent positive, so I'm going to move it to the top. When I change position, it'll change the sign of the exponent. So I'm going to write the 3. I have the 3 on top. Now the 6 is going to come up top, and the exponent will turn to a positive 1. But I'm going to just leave the 1 out, because anything to the first power is itself. All right, and then we have d to the negative 6. So I'm going to move that to the top. And so the d will come up, and that'll make that exponent positive. Okay. All right, now notice anything you bring to the top, you're multiplying by whatever is already on top, right? And so in this case, 3 multiplied by 6, right? Those are just constants, so I'm just going to multiply like we normally would. 3 multiplied by 6 is 18. And then the d to the 6 can't be simplified, so I'm just bringing that over, and that's the final answer. So 82, similar situation, right? I want to move this to the top to make that exponent positive. I'm going to move this to the bottom to make that exponent positive. The 2 here can stay. It has its own exponent of positive 1. The n squared can stay because its exponent is positive, so it's fine where it is. So 2 is going to stay. 3 is going to come up. Its exponent will turn positive, so 3 to the positive 1. I'm going to leave out the 1. Anything to the first is itself. The m's going to come to the bottom, and its exponent will turn to a positive 4. And then the n squared will stay on the bottom. And so now we can multiply 2 by 3. We get 6. M to the 4th, n squared. We can't do anything with those. They're not like bases. So we just leave it like that. All right. Should do a better job with my m here. There we go. All right, and then the last example on this page, number 84. So we have a power rule happening here, right? Exponent on the outside, power of a quotient and a product actually. And I could multiply this, right? But if I multiply this first, I would multiply it 4 times, right? So instead of doing that, what I recommend, even though that will result in a correct answer, as long as you, take correct steps along the way, what I'm going to do is simplify these because these are all C's, so I can use my properties, my exponent properties, to reduce that down to 1C with one exponent, and then I'll just have to multiply once instead of multiplying 4 times. And so that's what I'm going to choose to do. I could also flip this first if I wanted to, but I'm just going to wait and see what happens on the inside first. So first thing I'm going to do is I'm going to remember that the numerator and denominator have their imaginary group and symbols, right? So I'm going to deal with each of those independently first before I divide. Okay, so I'm going to do the numerator simplification. So I have c to the negative fourth times c to the negative second. So I'm going to add those exponents. So negative 4 plus negative 2 is negative 6. Right, so that'll be on top. On the bottom, I'm going to add these exponents, negative 6 plus 8. And that gives me positive 2, right? And then I still have the negative fourth on the outside. All right, so now I'm going to use my quotient rule and subtract, okay? So I'm going to subtract the exponents. So I'm going to do negative 6 minus 2, right? Subtract these exponents, and that'll give me negative 8. Okay, still have the negative fourth out here. So now I can actually multiply these exponents, right? And so remember I could have flipped it a while back, but I can see now if I multiply a negative by a negative, I'll get a positive. So I'm just going to multiply and let nature take its course, right? So negative 8 multiplied by negative 4 is positive 32. And that's as far as we can go, right? We have a positive exponent. We have only one C left, one base with one exponent. And we don't have any constants that we can simplify. So that's as far as we can go.